everyone. Welcome to GNANA DEEKSHA Concept-Based Digital Learning. I am N.Roja, PGT Math, working at TSWREIS Girls Cultural in DEEKSHA. Math riddles are fun and challenging. Riddles help us to develop interest and aptitude in mathematics. Let's see how fast you can solve this riddle. What number do you get when you multiply all of the numbers on a mobile's number pad? The answer is 0, right? Because we have the digits 0, 1, 2, 3 to 9 on the number pad, and we know that any number multiplied by 0 is 0. Hence, the answer is 0. Learning is fun. Learning never exhausts the mind. You get to know so many things every day. The beautiful thing about learning is that nobody can take it away from you. Today, we are going to learn and discuss the following concepts. Recall the concept of highest common factor, methods to find HCF, Euclid's division lemma, Euclid's division algorithm, and its significance. Let's recall the concept of HCF, which is useful before we learn Euclid's division lemma. Amy had 12 pencils. She wanted to arrange these pencils in such a way that each row has same number of pencils. Let's see what all she tried. First, she arranged 12 pencils in one row. So, the number of rows is 1 and the total number of pencils is 1 into 12 is equal to 12. Or, she can arrange one pencil in 12 rows. That is, 12 into 1 is equal to 12. Next, she arranged like this. Here, number of rows is 2. In each row, 6 pencils are there. So, the number of pencils is 2 into 6 is equal to 12. Or 2 pencils in 6 rows. That is, 6 2s are 12. Later, she arranged 4 pencils in each row. So, the number of rows is 3 and the number of pencils is 3 4s are 12. Or 3 pencils in 4 rows. That is, 4 3s are 12. Now, let's see all the arrangements which work for her. 12 pencils in 1 row, 6 pencils in 2 rows, 4 pencils in 3 rows. Here, the pencils are arranged in such a way that number of rows into number of columns is equal to 12. These numbers 1, 2, 3, 4, 6 and 12 are exact divisors of 12. They are called as factors. Next day, her father bought 16 blue pens for her. Now she has 12 pencils and 16 pens. Again, she wanted to arrange 12 pencils and 16 pens into groups so that no pencil or pen is left out. Also, each group should have same number of pencils and pens. Okay? Here, the number of pens is 16. How do we find the suitable arrangements for 16? Yes, by finding the factors of 16. They are 1 16s are 16, 2 8s are 16, 4 4s are 16. So, 1, 2, 4, 8 and 16 are factors of 16, right? What do you mean by 1 into 16? 1 row with 16 pens. Is this arrangement suitable for 12 pencils? No, because the row with pencils is partially filled. Next, the arrangement of 2 into 8 is well suited for 16 pens, as two groups have 8 pencils each. But it will not work out for 12 pencils as the second group is partially filled with 4 pencils. So, what is the solution? Can there be a common arrangement for both the cases? To know this, we need to find HCF of 12 and 16. Highest common factor or greatest common divisor. HCF of two or more numbers is the highest or greatest among all their common factors. Let's see how many groups or arrangements we can make by finding the HCF of 12 and 16. We will follow a 3-step process here. Step 1. Find all the factors of given numbers. 1, 2, 3, 4, 6 and 12 are factors of 12. 1, 2, 4, 8 and 16 are factors of 16. Step 2. Find the common factors among the given factors. They are 1, 2 and 4. Step 3. Find the greatest or highest of these common factors. Which is the highest of 1, 2 and 4? It is 4. HCF of 12 and 16 is 4. Hence, we can make 4 groups. But how many pencils and pens should be there in each group? To find this, we divide 12 and 16 by HCF. 12 divided by 4 is equal to 3. 16 divided by 4 gives 4. Hence, we can make 4 groups such that each group have 3 pencils and 4 pens and no item will be left out. Now, let us recall the methods to find HCF. We have 2 methods to find HCF of 2 or more numbers. One is using multiplication, another method is using division, which are very simple methods. Let's see how to apply HCF in real life. Suppose there are 18 students in class A and 27 students in class B. Each class divides into teams to prepare for the tournament. The winning team of each class plays each other in the final tournament. Here, we need to divide class A and class B into teams so that each team has same number of students and no student is left behind in any class. To define the biggest possible team size, we will find HCF of 18 and 27. Let's find HCF using prime factorization method. Prime factors of 18 are 2 into 3 into 3. 2 3s are 6, 6 3s are 18. Prime factors of 27 are 3 into 3 into 3. 3 3s are 9, 9 3s are 27. Now, identify the factors which are common to both and multiply. That is, 3 into 3 is equal to 9. Therefore, HCF of 18 and 27 is 9. So, the biggest possible team size is 9, which means each team will have 9 students. Another method of finding HCF is by successive or continued division method. Let us find HCF of 18 and 27 using division method. We divide bigger number by the smaller number, that is 27 divided by 18. Here 27 is the dividend, 18 is the divisor. Let's perform division. 18 ones are 18. Remainder is 9 and 1 is the quotient. If we get the remainder as 0, then the divisor is the HCF of given two numbers. But remainder here is not equal to 0. So we cannot say the divisor 18 as the HCF. So to find the HCF, we will consider this remainder 9 as the new divisor and the previous divisor 18 as the new dividend and continue to divide. That is 18 divided by 9. 9 twos are 18, so remainder is 0. So we stop the procedure here and the divisor in this step, that is 9, is the HCF of 18 and 27. Division method is much faster and easier method to calculate HCF. Now, let's try to represent the first division 27 divided by 18 mathematically. 27 is equal to 18 into 1 plus 9. 18 ones are 18 plus 9, which is equal to 27, which is nothing but dividend is equal to divisor into quotient plus remainder. Again, the second division can be represented as 18 is equal to 9 into 2 plus 0. 9 twos are 18 plus 0 is equal to 18, which is same as dividend is equal to divisor into quotient plus remainder. This statement is known as Euclid's division lemma. Now, replace the numbers by variable. That is, replace dividend by the variable A, divisor by B, quotient by Q, and remainder by R. Then it looks like A is equal to B into Q plus R, which is same as dividend is equal to divisor into quotient plus remainder, right? The Greek mathematician Euclid, often referred to as the father of geometry, came up with an idea and proved that whenever two positive integers, say A and B, are divided, we get two more positive integers, say Q and R, in the form of quotient and remainder, and they can be arranged as A is equal to BQ plus R, where 0 is less than or equal to R is less than B, which means remainder can be either 0 or cannot be greater than the divisor. This result was first recorded in Book 7 of Euclid's Elements, and this type of representation is called lemma in Greek, and since this is proved by the Greek mathematician Euclid, it is called as Euclid's division lemma. Now, what is a lemma? A lemma is nothing but a proven statement used for proving another statement. It is a self-proven statement which can be used as a fact. For example, the sun rises in the east. Euclid's division lemma has many uses. It is used to find HCF between two large numbers. Children, let me tell you a small story. A trader was moving along the road selling the eggs. An idler who had nothing to do called the trader. Instead of buying eggs, he started irritating him. He was just wasting trader's time. Soon it led to a fight. He pulled the basket with eggs and threw it on the floor. The eggs broke. The trader dragged him to the king's court and demanded compensation from the wicked man. The king understood his appeal and asked the trader how many eggs were broken. The trader loved math. He replied, "If counted in pairs, one will remain. If counted in threes, two will remain. If counted in fours, three will remain. And if counted in fives, nothing will remain. And my basket cannot accommodate more than 50 eggs." Let us understand what the trader said. Okay? Say that the number of eggs is 8. Then, working backwards, we see that A is less than or equal to 50 because the basket cannot accommodate more than 50 eggs. So, number of eggs is less than or equal to 50. The trader said, "If the eggs are counted in fives, nothing will remain," which means that the total is exactly divisible by 5 without leaving the remainder, which translates to A is equal to 5m plus 0, where m is the quotient and 0 is the remainder when A is divided by 5. Next, if counted in fours, 3 will remain, which means that when the total is divided by 4, remainder is 3, which can be written as A is equal to 4n plus 3. Next, if counted in threes, 2 will remain, which is translated to A is equal to 3p plus 2. Next, if counted in twos, 1 will remain, which can be written as A is equal to 2q plus 1. So, we represented what the trader said in the form of equation. Now, to solve it, we must look for the multiples of 5 which satisfy all the conditions, because if the eggs are counted in 5, nothing will remain. That is, A is equal to 5m plus 0. So, the multiples of 5 less than or equal to 50 are 5, 10, 15, 20, 25, 30, 35, 40, 45 and 50. So, the answer to this puzzle is one of the multiples of 5 which is less than or equal to 50. Now, out of these 10 numbers, which one gives the exact number of eggs? Find out. In these 10 multiples, 5 are even and 5 are odd numbers, right? But the criteria A is equal to 2q plus 1 means that the number leaves remainder 1 when A is divided by 2. Isn't it? Now tell me, which numbers leaves remainder 1 when divided by 2? Yes, odd numbers. So children, we got another clue that the answer must be an odd number. So let's cross out the even multiples of 5 as we must consider odd multiples only. So the possibilities are 5, 15, 25, 35 or 45. Let's check the other condition. A is equal to 3p plus 2 means the number leaves remainder 2 when it is divided by 3. What are such numbers out of 5, 15, 25, 35 and 45? let's divide each of the numbers by 3 and check. They are 5 and 35. So, the possibilities are either 5 or 35. Now, let's check the last condition. A is equal to 4n plus 3, which means the number leaves remainder 3 when it is divided by 4. When 5 is divided by 4, remainder is 1. When 35 is divided by 4, remainder is 3. So, the desired number satisfying all the conditions is 35, which means the trader had 35 eggs in his basket. Let's verify the answer. When 35 is divided by 2, remainder is equal to 1. The division can be written as 35 is equal to 2 into 17 plus 1. 2 17s are 34 plus 1, 35. When 35 is divided by 3, remainder is 2. It can be written as 35 is equal to 3 into 11 plus 2. 3 11s are 33 plus 2, 35. When 35 is divided by 4, r is equal to 3. It can be written as 35 is equal to 4 8s are 32 plus 3, which is equal to 35. When 35 is divided by 5, remainder is 0. It can be written as 35 is equal to 5 into 7 plus 0. In the process of writing above equations, we used Euclid's division algorithm unknowingly. For each pair of positive integers a and b, we have found two whole numbers q and r satisfying the relation a is equal to bq plus r, where 0 is less than or equal to r is less than b. Now children, what is Euclid's division algorithm? Euclid's division algorithm is the process of applying Euclid's division lemma several times to obtain HCF of any two numbers. It provides a stepwise procedure for calculating HCF of any two positive integers. To obtain HCF of any two positive integers, say a and b, with a is greater than b, follow the steps given. Step 1. Apply Euclid's division lemma to a and b and represent it as a is equal to bq plus r, where 0 is less than or equal to r is less than b. Step 2. If we get the remainder as 0, the divisor will be the HCF of given two numbers. If remainder is not equal to 0, we apply this lemma to b and r. Step 3. Continue the process till the remainder is 0. Then the divisor at this stage will be the required HCF. The process when we apply this lemma to get the remainder as 0 is called Euclid's division algorithm. You must be thinking, what is the real life significance of finding HCF of two numbers, right? Euclid's division lemma or algorithm has several applications related to finding properties of numbers. It is used to find HCF of two large numbers. The concept of highest common factor is used in production, purchase, arrangements, etc. HCF can be used to split things into smaller sections, like dividing a class into teams, to equally distribute two or more sets of items into their largest grouping. It is used to figure out how many people we can invite. It is also used to arrange something into rows or groups, like arrangement of pens and pencils into groups, etc. To understand this more clearly, let's look at a real-time scenario. Imagine you have a window of size 40 centimeters into 15 centimeters. 40 centimeters is the length and 15 centimeters is the width. You want a fixed grill to your window. What is the maximum gap you can leave such that the spacing between the bars is equal? We need to find the maximum spacing between the bars. The way to find is HCF. HCF of 40 and 15. The highest number that divides length 40 centimeters and width 15 centimeters using Euclid's division algorithm. Step 1. Let A is equal to 40 and B is equal to 15. Also, 40 is greater than 15. So apply Euclid's division lemma to 40 and 15. 40 divided by 15. Represent the division as A is equal to BQ plus R. Dividend is equal to divisor into quotient plus remainder. That is, 40 is equal to 15 into 2 plus 10. Step 2. Here the remainder is 10. As the remainder is not equal to 0, apply the lemma to the divisor in step 1 and the remainder. The divisor in step 1 is 15 and the remainder is 10. So divide 15 by 10 and we represent it as 15 is equal to 10 ones are 10 plus 5. Step 3. Again the remainder is not equal to 0. So apply Euclid's division lemma to the divisor in step 2 and the remainder. That is 10 divided by 5 and represent it as 10 is equal to 5 into 2 plus 0. 5 2s are 10 plus 0. Here the remainder is 0. So we cannot proceed any further. The divisor at this stage is the HCF. Hence, HCF of 40 and 15 is 5. So, maximum gap between the bars should be 5 centimeters. This is Euclid's division algorithm of numbers. Hope you are clear with the concept. Let's go back and check what all we have done in this session. The highest or greatest factor common to any two or more numbers is HCF, and we discussed the methods to find HCF of numbers, the math journey around Euclid's division lemma, and finding HCF using Euclid's division algorithm. Isn't it fun solving the problems using Euclid's division algorithm? Try this. Golo is emptying 2 water tanks that are filled with water using a jug. The water tanks have capacities of 420 liters and 130 liters. What is the maximum capacity of the jug he should use so that no water remains in the tanks? You need to find the maximum capacity of the jug that can empty water from the 2 tanks completely. So, you need to find HCF of 420 and 130 applying Euclid's division algorithm. That's all for now. My heartfelt thanks and gratitude to our secretary, Dr. R.S. Praveen Kumar Sir, our RC, Nirmala Ma'am, Principal Ravindra Prasad Sir, and Imaditi Kishore Sir. Thank you, class. Happy learning.